So today, in my presentation, I just want to focus on the query aspect. The query aspect of the stack is how do you take input from a user in English and how do you convert that into interface into your storage? Like how do you do that? That's the problem I want to focus on. The query problem stated again is take an English phrase and convert it into a query. Like how do you do that? You essentially do that in 2 steps. So this is the stack. Your data is coming in from the bottom, and you've stored the data. The first step in solving the query problem is you need to have a uniform query interface to your storage layer. Even though it's SNMP at the bottom or Kafka, what have you, you need to decide on a uniform query interface. And why that uniform query interface is important will become evident later on. And we've settled on SQL as that uniform query interface. SQL is a language, I learned about it when I was in college. There have been many SQL killers along the way, but SQL has not died and will never die. It is a rich language which gives you it lets you declare everything that you might want to have in a query interface. So we decided we don't have to reinvent the wheel. We're going to model our query interface on SQL. Mind you, it doesn't mean that we have a SQL engine running in our system and we are doing SQL queries. That's an implementation thing because SQL traditionally was meant for business intelligence data, like sales records and all of that. So if you were to run a SQL engine on your SNMP data, it's going to crawl. It's not going to go anywhere. What we mean by SQL over here is the API is modeled around SQL, so that any client, if they can talk to a SQL engine, they can talk to Selector, right? And by the way, the name Selector, the /select, which is part of SQL, that's why we named us a selector, because we modeled ourselves as a SQL database, and select is the most important statement in a SQL query, hence we call selector. Right? The first step is you have a SQL-based interface, and then you deploy an LLM that's able to take English phrases and convert to SQL. Right? So you solve the problem in 2 ways. First, you have a SQL interface, and then you train the LLM to take English and convert it into SQL. So now let's see how do we go about doing these 2 things. Just a primer on SQL, like how is SQL relevant to networking data? A few slides on that. So just as background, SQL is structured query language. So it has really 2 parts to a SQL query. If somebody does a SQL query, you say, so SQL says you have a bunch of tables in your system, and which table are you interested in querying? So you select and you give the name of a table, so that SQL knows, okay, I'm going to go fetch data from this particular table. And then it has a set of filters, because presumably you do not want to load the entire table. You want to load a few columns, or you want to load a few rows. So it has a very rich filtering syntax. You can say, and you can give it a list of filters, filter 1, filter 2, filter 3. So table is what data to return, and filter is to prune the data that is being returned. So that's SQL. So if you were to look at the interfaces error table, so interfaces errors that we get from routers and devices in the form of a SQL is going to look like this. It has a bunch of columns: device name, interface name, device role, customer, whatever are your meta tags that you've used to enrich the interface data. Those appear as columns in your table. And then you can say select from interface errors, and the different filters that are going to be available to you are the different columns: device, role, and so on and so forth. The BGP table, this is the tenants table. If you look at a multi-cloud environment, there are no interface errors over there. In there, the data set is who is my tenant, who is the cloud provider, what is the virtual router that I'm using, what is the region in which things are happening. So their data is organized along these rows. So it's a different table. It has different rows. It has different columns. And if you want to query it, you have the corresponding things. BGP peers. BGP peers table is again local peer IP, remote peer IP. What is my local ASN? remote ASN, the different columns, and SQL is able to represent this. You're able to, so now you can see, if you were to get your BGP data from OpenBMP or by polling some BGP OID, you can take that data and logically store it in a table that looks like this. Then you can have a SQL interface to read that data. Right? Filtering is again the most important part. So select from IF table where device equals to router 1. Or you can say where role equals uplink. For some reason you want to see what are my interfaces where the role is equal to uplink. You can say, not only do I want role equals to uplink, I want to do my device equals router 1. So SQL allows you to give all of those things. So now we've said we have SQL as the uniform language to query our databases. Now the second aspect is you interface the LLM, and the LLM is going to take the English phrase. The English phrase is show me errors in Ashburn. So that English phrase, show me errors in Ashburn, now needs to be converted into the right SQL query. That's what the LLM is supposed to do. Because if we take the phrase and the LLM converts it into the right SQL query, and we've just learned that SQL, we can query the underlying storage, then our chain is complete. By this English phrase, we are able to get our data.
Would you also be able to interwork with, say, an Oracle Select AI capability that does the same kind of thing? Say the customer, we went at selector AI, but we like our Oracle implementation
of the model?
Yeah. Well, just being able to do English to SQL.
Sure. Yes.
Okay.
Yes.
Good to know.
And why am I comfortable saying yes to that? We've used Kubernetes microservices architecture to be able to talk to different components. So even our services inside talk to other services using API calls. So the translation service, the translation service doesn't have to go to our LLM. It can go to an external API and get the answer to that. The only challenge in such interactions is usually latency. Because if it is not close by, that API call is going to take some time to come back. So that sometimes becomes an issue. It can be solved by co-locating it over here, but and of course security and all that.
Is it possible for your customers to access this LLM in this way? Like, do you have an API that says, hey, here's my English query, and it returns back the SQL query back, and then they could use that information how they want to?
Yes, we don't have anybody doing that, but the plumbing is in place that once you can have the output of the translation layer not go to the query layer, but be reflected back up how the thing came through.
Okay, cool.
And we have that. You'll see in the demos later on, our portal needs to know what query actually got implemented. So the portal actually displays the underlying SQL query. So if the portal can get it, because the portal is also a foreign application from the stack, customers can also get that.
Cool.
And the other use case for something along those lines is to build trust in the system. Because people, there's a lot of false marketing around technologies like this. So you need to be able to show customers that here are your queries that you might have. These are English sentences. These are the corresponding SQL queries that Selector will generate. So there is a very little investment on their side to be able to see the output. And once they see that and then they understand it, they say, yeah, this is reality. It's not just marketing. So now let's get into the LLM world. How do we get the LLM to do what we want it to do? So the problem for LLM.
Before you go any further,
yeah,
are you going to cover any details about the managed service, how that works, how you store the customer data? Because I have a couple of questions around that from a data privacy, segmentation, separation perspective.
So Michael, I wasn't planning on covering that right away. What I'll do is let me finish the LLM track, and then at the end we can have a separate session on that.
Great, thank you.
So now let's take an English sentence which says, are there any errors? Are there any port errors in Ashburn across my 100 gig ports in the last 2 days? That's the English sentence that the user has entered. The LLM has to figure out two parts to it. First, it needs to infer that you are interested in interrogating the interface errors table. That user intent is hidden in that. You and I, as humans, can clearly see it, and we need to query the port error table. But the machine, the LLM, needs to infer what table to go after. It might not be a single table. It could be multiple tables because the intent might spread across multiple tables. So its first job is to figure out what are the underlying tables that I need to go query. And second, there are keywords that the user has provided. The user has said last 2 days. The user has said Ashburn. They have said Gigi 100 star. So those are keywords. Those are nothing but filters that have to be applied on that table. Right? So the job of the LLM is really, I know if I were to enter a SQL query, it would have said select IF errors where site equals Ashburn, port equals Ethernet star, time frame equals 48 hours, because those are the columns in my underlying table. The LLM needs to be able to take that English sentence and slot those different things in the right slots. That is its problem. Right? How does the LLM do that? We're going to talk about that next. Because if you're able to do this successfully, now you can see that I can enter any English statement, and the LLM needs to be able to parse the English statement, find the right keywords from the statement, slot them in the right SQL queries, and go query the storage. Maybe it's not one query. There are 5 different queries that are needed for you to be able to satisfy what the user had said. It'll generate those 5 queries. Or you do some ETL work up front, make sure all the data is present in one table, so there's a single query. Those are secondary implications of what needs to be done, but this is the high order bit. The LM needs to be able to figure out the intent, what table, and what are the filters.